Hello, Mr. McDonald's class. My name's Evan. I'm going to be helping out with your engineering project this term. You guys have been learning a lot about engineering, about electricity, and about magnetism. And so we're going to put all of those three together to build a launcher. And my guess is you guys have heard bits and pieces about this, and there are a ton of ways to use electricity and magnetism to build a launcher. But I wanted to tell you today about a couple of the specifics of the project and what the overall goal of this project is going to be. Okay, as with any good science project, we're doing science with a purpose here. And the purpose is this. Benjamin Franklin, one of the pioneers of electricity and magnetism in the United States, has been locked up. The British have decided they don't want him causing trouble. They've put him in jail. And as a result, everything that he has discovered, everything that he's learned, and everything that he has to teach us is at the risk of never being known and never being seen again if he spends the rest of his life in prison. So here's what we're going to do. We're going to break him out. We're going to use the launchers that you guys are going to build. And we're going to use those launchers alongside a track that I've helped build. And if your launchers work well, and if my track works well, we're going to bail him out of prison. And today I want to show you a little taste of what that track will be like, not the final thing. And hopefully if you guys can see that, then you'll have an idea of what you're supposed to bring to the table and what your launchers are going to need to accomplish. And we can do this thing together. Let's take a look. Okay, we're going to go into the details of this track in just a second, but I want to show you a physical model of what it looks like, and you guys can have a sense for what you need to build in your launchers. So your launcher will go right here, and this is not the final track, this is just a prototype. But your launcher will go right here, and your launcher will launch something, you get to choose what, through this coil, and this coil is acting as a magnet. As you do that, you'll generate electric current. And if you generate enough electric current, doors will open. There are no doors on the prototype, but in the final, doors will open. And on the other side of those doors, Ben Franklin will be there waiting in his cell for you. Now, once that's open, your projectile will keep moving, and it'll knock into Ben Franklin, and you'll send him down this escape route. And what we have is a jump, where if he's going fast enough down that jump, he'll be able to jump through the window, over the guards, escape to freedom. For this demonstration, I'm going to use a blue marble, to represent Ben Franklin. And we're going to put him here at the end of the coil. Then I'm going to use a red marble to represent the object that you'll send through the coil using your launcher. And to represent the launcher, I'm just going to use my finger. Now, you guys aren't going to use glass marbles. You're going to use things made out of metal. And you're definitely not going to use your finger as a launcher. You're going to use something electromagnetic and much more cool. But this shows the idea of sending an object through the coil to knock into the Ben Franklin object, and then to send him down this jump and hopefully to freedom. So let's take a look and see if that works.
Let's dive into exactly what this project looks like. In this diagram, you can see we start with a silver ball on the far left. That silver ball represents whatever it is you decide to launch out of your launcher. It could be a steel ball, it could be a magnet, so long as it's made of metal, it can be anything you want it to be. Next to that, the golden arrow represents your launcher, and that can look like whatever you design it to look like. With your launcher, you're going to use what you've learned about electricity and magnetism to propel something through this track we've designed for you. The first part of that track is a coil, and that coil is going to act like a magnet. So as your metal object moves through that coil, you're going to change the magnetism within that coil. What that does is generate an electric current. You're using magnetism to generate electricity. If the electric current that you generate as your metal object moves through that coil is high enough, if if you generate enough electricity, you'll be able to open the doors into Ben Franklin's cell. If you don't generate enough electric current, those doors won't open, and you won't be able to make it onto the next part of the track. But let's assume you do. Let's assume those doors open wide. What happens next is you make it into Ben Franklin's prison cell, and he's sitting there waiting for you. What your metal object is going to do is knock right into Ben Franklin. And he's sitting on this cart ready to go down a big ramp. As he goes down that ramp, he'll speed up, and at the very end he has this jump through the window to freedom.
Now you have to be careful, because there might be guards outside, there might be someone out there making sure that Ben Franklin doesn't try to make a run for it. But if you manage to get your launcher to knock something into Ben Franklin with enough force, you'll send him just screaming down that ramp and off that jump, no problem. He'll clear anything that's outside. And so he'll be free. And more importantly, maybe, everything that he learned and everything that he can teach us about electricity and magnetism won't be lost just because he's stuck in a jail cell. Okay, we have two more things to talk about, constraints and goals. And these are probably the two most important takeaways about this project today. So constraints are limits on your design that make it work within the context that you're trying to build something. And we're going to tell you for this project what your constraints are.
Your constraints are, first, your launcher needs to use electricity, magnetism, or both. Some part of your launcher needs to put into play the ideas about electricity and magnetism that you've learned to make something move. Second, the object that you launch has to be made of metal. No glass marbles, no wooden beads, anything like that. So long as it's made of metal, though, it can be anything you like. It can be a steel ball, a magnet, a battery, anything you can think of. Third, whatever you launch needs to be able to move through a 1-inch diameter plastic tube. That's what'll be between your object and the copper coil. So it needs to be able to move 12 inches through the plastic tubing to make it the entire way through the coil. Finally, we'll provide supports to get your launcher to the right height, but it can't be more than 10 inches tall. If it's more than 10 inches tall, it'll be too tall to launch through the magnetic coil, and you won't be able to get your object onto the track.
Finally, let's talk about your goals. And this is up to you. As a class, you get to choose what your goals are. We're going to measure 3 things, and then among those, you get to pick which of them seem the most interesting, the most important for you to design around.
We'll allow you to sense the amount of current that you generate through the magnetic coil. We'll allow you to sense the force that your object knocks into Ben Franklin with. And we'll be able to measure the distance that Ben Franklin makes it once he's jumped out of the window.
So with those options in mind, you get to choose what's most important to you, what's most interesting for you to design for. Is it current? Is it force? Is it distance? That's up to you. We're going to leave you to make that decision. That's all I have today. Happy designing, happy building. I can't wait to do the rest of this project with you guys.